Hello and welcome to the first video on simplifying expressions. So let's start by asking the question, what is an expression? So an expression, so I'm going to write an example of an expression here. So here's a simple expression, 2 times x plus 3 plus 5x. That is an expression. We can compare that with this one here. That is an equation. So this here is an equation. Now the difference between expression and equation is, of course, the equal sign, right? Right there, that equal sign, and that makes a big difference. We solve equations. You solve equations. Equations are solved. Expressions are simplified. Okay, and the reason I'm making a big deal of this is I will often see students when I ask them to simplify an expression like this, I will often see them throw an equal sign into the problem and solve it. Well, it didn't start with an equal sign, so it shouldn't get an equal sign. So this one here is simplified. Now we'll start by doing some simple things with expressions and simplifying expressions, and then we will move on to more complex examples in another video. So let's take a look at the basic expression here. So example, simplify, and I'm going to do some what you would think are very easy examples. Bear with me because the point is to start slow. Okay, so here's the first example. 1. We will do -4 times 5x. I want us to just kind of get used to this idea. So if you look through this whole thing here, it's all multiplication, right? What's the glue that holds all the pieces together? Now this one here has 4 pieces. The glue that holds this to the next rest of it is multiplication. The glue that holds the 5 to the x is multiplication. So it's all multiplication. That's the glue that's holding everything together. So that's all we do. So we can say, using the associative property, if you remember multiplying association, we can say this is the same as multiplying those two times x, and using what we know about multiplication, 4 times 5 is 20. Since 1 is negative and 1 is positive, that's going to be negative 20. Right? So that was using the associative property. Let's take a look at another problem. 9x plus x. Okay. Now this one here, so some of you already know what the answer is. You're probably thinking ahead in saying the answer to this is 10x. Fine, that's true. But let's dive a little deeper and make sure we understand why that is 10x. Okay, so first thing to understand is this is 9x multiplication added to, and well, what's the number in front there, right? Well, we can go to the identity property of multiplication, and we know that that is the same as 1 times x. And so again, you can sort of see where you get the 10 from. 10 comes from adding the 9 plus 1, right? So this is 9, so this is the identity property we are using. And 9 plus 1 is your 10x, right? So same thing, you can do it fast, or you sort of see all the pieces that are going on there. Now, we also, so this problem actually has a lot of details to it that I would really like us to spend a little time making sure we understand this. So here is our problem. And I said just a moment ago that this is the same as saying 9x plus 1x. So another way to approach this is to say, combining like terms. You probably heard that phrase. So combining like terms, right? And that is exactly what you're doing. So these pieces that are separated by a plus or a minus, add or a subtract there, add, subtract. Oop, should be subtract, S-U-B, add, subtract. These pieces that are combined using an add or a subtract, these are called terms. So each of these is a term. And if you look at a term, so if you focus in on one of these terms, so if you just take, say, the first one, there are clearly two parts to it. This part in the front, that part there, the number, that's called the coefficient. And this part here, that's the variable part. That's the variable part. And we say two terms are alike if their variables match exactly, right? So if you look at 9x and this x part, the two terms in our problem, and we focus only on the variable piece of the problem, like so, since they match exactly, since they're exactly the same, these are like terms. So 9x and x are like terms. Okay, and when you have like terms, you can combine like terms. So you can combine like terms by adding the coefficients. So in this case, we can take the 9x and the 1x. We identify, oops, that didn't come in black. We identify that they are like terms by looking at the variable part, and then we can add the 9 and the 1 together and write that as 10x. Now I know I've gone through this super slowly, and some of you are sitting there going, boy, that was a long explanation for that simple problem. And you're right, but I really want us to make sure that we get the simple stuff firmly under our belt before we move on to doing more complex things. So let's take a look at another simplify problem, right? So simplify example, and this time we'll get a little more creative with our variables. So for example, let's say we did 9xy squared minus 2x squared y plus 3xy squared minus x squared y. So now if you look at this problem, first of all, what you want to do is identify the like terms. So to identify the like terms, you start to scan through the problem and you start to compare the variables to one another. Now this is confusing in this problem on purpose because they all have x and y to them. However, they're different. So this here, right there, the first term right there, has an x and a y squared. That does not match with this second term, which has x squared with y. So really, the two things that match are this one here, this term right there, and this term right here. Those are the two terms that match, right? And then we can say, if you compare the variables of the second term right there, x squared y, that matches with that x squared y, right? So what you can combine here are the first and the third can be combined, and the second can be combined with the fourth. So that's exactly what we're going to do. Now, all this happens very fast, hopefully. You should be able to scan through there and say, okay, so xy squared, I'm looking for xy squared. Okay, I see an xy squared and another xy squared. So to combine those two together, I'm going to add the numbers in front. So that in this case, that's a 9 and a 3. If I add the 9 and the 3, I get 12 xy squared. Now, this is something I do just to make sure that if I have a complicated expression that I've gotten them all, I sometimes cross these out when I combine them. So that way I know I've combined it. Then I go on to the next pair. So the second and the fourth. So we saw in the previous example, there is a 1 that sits in front here. Right? So really what we have to do here is the coefficient in front here, the number in front there is -2. So it's really -2 added to -1, which is because of the negatives. So that works out to be -3. So this is -3x squared y. And there it is. There is my answer combining those two like terms. Alright, so I think that's enough for simplifying introduction. We'll take this same conversation up in a second video coming up.